In the previous video, we found the derivative of sine x to be cos x, and we proved that using the limit definition of derivatives, or also known as first principles. Now what we can do is we can derive the other trig functions using this, which makes it much quicker and easier. So let's first start with the derivative of cos x. Now, the derivative of cos x, let's first see if we can rewrite that as sine x. Now you know that using co-ratios, cos of an angle can be written as sine of pi over 2, which remember used to be 90, but now we refer to it in radians, minus x. And going back, the derivative of sine of an angle is cos of the angle. So we know that we've got the derivative of sine of an angle is cos of that angle, which is pi over 2 minus x. However, we're dealing with the chain rule. So now we've got to go inside and find the derivative of pi over 2 minus x. Well, the derivative of pi over 2 is a constant, is 0, and the derivative of negative x is negative 1. So we're left with negative, there's our negative 1, and cos of an angle minus x is just sine of that angle. So we know from that that the derivative of cos x is negative sine x. So that's our conclusion. Let's have a look at the derivative of tan x. When we do the derivative of tan x, we can now use this result as well, that the derivative of cos x is negative sine x. We will need to use that. Okay, so the derivative of tan x, let's first rewrite tan x in terms of sine x and cos x. So I'm dealing with the derivative of sine x over cos x. Here I'm going to need to use the quotient rule. So I need to first find the derivative of the numerator. The derivative of sine x is cos x, multiplied by the function in the denominator as it stands, minus the function in the numerator as it stands, multiplied by the derivative of the denominator, which the derivative of cos x we've just found is negative sine x, divided by my denominator squared. So that gives me cos x times cos x is cos squared x. Negative and negative is a positive, plus sine squared x over cos squared x. Now we know that cos squared x plus sine squared x is our square identity, which is just 1. So we've got 1 over cos squared x, which gives us our reciprocal trig function, sec squared x. So from that we know that the derivative of tan x is sec squared x. Let's now have a look at the derivative of cosec x. Firstly, I'm going to rewrite it in terms of sine. We know that cosec x is 1 over sine x. And again, I'm going to have to use the quotient rule. So the derivative of my numerator, which is 1, derivative of 1 is 0, times by the function in the denominator, which is sine x, minus the function in the numerator, which is 1, multiplied by the derivative of sine x in the denominator, which is cos x, all over the denominator squared. So obviously 0 times sine x is 0, so I'm left with minus cos x in the numerator and sine squared x in the denominator. Now what I'm going to do here is I'm just going to break this up a little bit to agree that this is exactly the same as negative 1 over sine x multiplied by cos x over sine x. See, I've still got both my sine x's there. Now 1 over sine x is cosec x and cos x over sin x is cot x. So what we have found here is that the derivative of cosec x is negative cosec x times by cot x. We're now going to have a look at the derivative of sec x. So I'm going to start by rewriting that in terms of cos x, so that's 1 over cos x. Again, I'm going to use my quotient identity. The derivative of 1 is 0. The derivative of, we're going to just write down the denominator, minus the numerator multiplied by the derivative of the denominator, which is negative sine x, all over the denominator squared. So 0 times cos x is 0, so I'm left with sine x over cos squared x. Again, I'm going to split it up, rearrange it a little bit to get 1 over cos x multiplied by sine x over cos x, which is sec x multiplied by tan x. So what we see here is that the derivative of sec x is sec x times tan x. Now the last one we're going to have a look at is the derivation of the derivative of cot x. So I'm going to rewrite cot x in terms of sine and cos, which we know is cos x over sine x. Again, I'm going to use my quotient identity, so the derivative of cos x is negative sine x multiplied by the denominator, which is sine x, minus my numerator multiplied by the derivative of my denominator, which is cos x, divided by my denominator squared. That gives me negative sine squared x minus cos squared x all over sine squared x. I can take out a negative in my numerator, so I get negative sine squared x plus cos squared x over sine squared x, which is negative 1 over sine squared x, which is negative cosec squared x, which means the derivative of cot x is negative cosec squared x. Let's just have a look at a summary of all those derivatives. Just to be reminded, you don't have to know the proofs, but you will be using the derivatives, and it's a good idea to know them even though they're going to be on your formula sheet. So let's just have a look at what they are. Put a line down the middle. And we're going to have a look at the original functions and their derivatives. We'll just summarize them. So the first one, we know that my original function sine x, the derivative of that is cos x. Okay, we've got cos x. The derivative of cos x we found to be negative sine x. The derivative of tan x we found to be sec squared x. The derivative of cosec x we found to be negative cosec x multiplied by cot x. Then we've got sec x. The derivative of that we found to be sec x multiplied by tan x. And the derivative of cot x we found to be negative cosec squared